So a prism is a polyhedron with two congruent faces. Those congruent faces are called the bases. Bases are the bases. I know there's no bases there, you just have to write it. For the notes you can. Go ahead, Phoebe, and pull bases for us so we can write that in your notes. Okay, so the basis is the repeating shape. So normally we think of bases as what's on the bottom and what's on the top. But sometimes they're going to push over our shape, and it might be what's on the left and what's on the right. So whatever shape repeats and is parallel is the base. So for this shape over here, it's the triangles that are the bases. And they're parallel to each other. Jacob, go ahead and pull the height of the prism for us. The height of the prism is the distance between our two bases. It's the line segment that connects the two bases. And then in this section, we are just focusing on surface area. So Issa, when you're ready, go ahead and pull the definition of surface area for us. So the surface area is the sum of the area of all the faces. So if you completely forget any kind of formula, you can just find the area of each face and add it together. We just have formulas for different shapes to save us time. So I don't want you guys to end up on a test and then not know how to do surface area because you're like, I didn't write that formula down. It's okay. Just find, we have enough information. We've done rectangles, we've done triangles, we've done parallelograms, we've done a bunch of shapes, even regular polygons. So you have enough information to find the area of each face and add it together. If the formula eludes you, do not stress about that. It'll be okay. Damien, when you're ready, lateral area. So the lateral area is the sum of the areas of the lateral faces. So lateral means not the top and the bottom, or not the bases. I think of it like this. If I am going to hug my prism, it's what my arms touch to give a hug. So we don't touch the top, we don't touch the bottom, we just go around the sides when we're talking about lateral. I don't know why that is why I remember it that way. That's just what I do. Okay, so it's the sum of the areas of the lateral faces, so just around the shape, not including the top and the bottom of the bases. Okay, so we're going to find the surface area of a right rectangular prism. If you don't know what that is, that's a box. So we're going to draw a box. So when I draw a box, I draw a rectangle first. Some of you guys did not take engineering design like me, so I understand that you don't know how to draw a 3D box. It's okay. It's not something we do every day, but hopefully my skill will help you in your future. Okay, so draw a rectangle, just like normal. We're going to draw from each corner a little diagonal line about the same distance in the same direction. So all these little lines are parallel, and then we're just going to connect them. And then we have a right rectangular prism. It's got a height of 8, a length of 3, and a width of 5. And the instructions tell us to draw it, so doggone it, we better draw it. One thing I need you guys to get better at is doing what the directions tell you to do. It's really hard to give you credit on your test when you don't do what the directions are telling you to do. Because that's what I'm grading you on. Okay, so we're going to take this box and squish it flat. So I'm going to draw this. It's called a net. When you draw three-dimensional figures squished flat, it's called a net. So the process for finding the surface area we're going to use for example 1 is called using a net to find the surface area. So the first thing I'm going to do is I'm going to draw this base. So it's the 3 by 5. Three by 5. And then on the right hand side of my 3 by 5 is going to be my 5, this rectangle right here. So he is 5 by 8. So he's going to be 5. So he is 5 by 8. He's on the right hand side. We have just unfolded this 5 by 8. I'm going to keep this train rolling around my shape. I'm going to draw the top next. So my top is 5 by 3. So this is the bottom. This is the right side. And this is the top. And it's 3 by 5. So I'm just unfolding this crazy guy. Unfolding him. Okay, so now I'm going to take this left-hand side. So I'm just going all the way around my box. I'm going to take this left-hand side. He is going to be 5 by 8, same as the right. So he is the left-hand side. So I've got the bottom, the right, the top, and the left. So I'm missing the front and the back. So I'm going to go to my bottom side, and I'm going to fold this guy in the front and put him in black. This guy in the front is going to come down below my bottom figure here. He is 3 by 8. So he's the front. So my front rectangle is going to be 3 by 8. And then I'm going to put the back side, that's this one right here, behind my bottom side here. And he's also going to be 3 by 8. That sits back. I don't know. You guys, my A kind of went south. So I've got the front and the back, the bottom and the top, and the left and the right. I'm going to find the area of each one of those rectangles. I can find the area of a rectangle. So when I call on you, you're going to tell me the area of the rectangle I'm pointing at. What is happening? So Sebastian, you ready? Area of the backside. Jack, area of the bottom. Nope.
15, what are you talking about?
3 times 5, Jack.
Sorry. I have Michael Jackson stuck in my head.
Andrew, area of the front. Let's circle it so you guys see. Katie, area of the right-hand side. 8 times 5.
40.
40. Okay. And then Peter, area of the top, 3 by 5. 15. And then Kai, area of the left. 4. Okay. So now we have to add all those together. Thankfully, with a rectangular prism, I have 2 of each. So I'm going to take each of my measurements and each of my areas and multiply it by 2. I have 2 24s, I have 2 15s, and I have 2 40s. So that's 48, that's 30, and that's 80. All we have to do is add those together, and our surface area is in inches squared. Some of you guys forgot your units on your chapter 10 test and lost points, and it was really sad.
158.
When we add all those together, we get 158 square inches. Area is always in inches. Perimeter is in inches squared. Area is in inches squared. Perimeter is in inches, and volume is in inches cubed. But we're not doing volume today. All right. Justin, can you read Theorem 11.1 for us?
The surface area of S of a right prism can be found using the formulas S equals 2B plus PH, where B is the area of base, P is the perimeter of base, and H is the height.
Remember, the height is the distance between the 2 congruent bases. The 2 bases. The 2 bases that are the same. A height is the distance between those 2. So I'm going to let the bottom be the base of this guy. So the area of this base, or our big B in our formula, so it's going to be, you're going to have to really watch it. It's big B is different than little b. Little b is the distance of, base times height that we've been using. So we got 50 inches squared for the base of the area of the base. We need to find, so if we're using the formula for perimeter, for surface area, we need to find the perimeter of the base. So some of my students yesterday were super struggling. It's not the perimeter of the front, it's not the perimeter all the way around, it's just the perimeter of this base, which is 10 plus 5 plus 10 plus 5, also known as 30. And then you want the height between your 2 congruent bases. So it's the distance from here to here. In this case, it's 6. So I've got the area of the base, the perimeter of the base, and the height of our prism. We're going to put that into the formula. 2 times 50 plus 30 times 6 gives us 100 plus 180. That gives us 280 square inches for our surface area. If all else fails, I can completely ignore this formula and find the area of each side and add those 6 sides together. I don't want you guys to get too far away from the fact that we're just finding the area of each of the faces.
Those are sides, right?
Huh? 5. Yeah. All right, so let's try this. This is a prism on its side. What is the shape of our base, Murph? The shape. So your choices are triangle or rectangle. Yeah, so the base of this is a triangle. So when I'm finding the area of the base, I have to find the area of that triangle. So yay, I have the base. Little b is 7. Unfortunately, I don't have the height. Don't have the triangle height. So this is the base of the triangle, boop, 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 and this is the height of the triangle. That height of the triangle is not the height we're going to use for our prism. So we're going to do our area of our base calculation first, since our formula calls for the area of the base. Okay, guys, what kind of triangle is on the front of this prism right here? 7, 7, and 7. Yeah, so it's an equilateral. So the angle measures are 60. And if I cut that in half, I get 30. Oh, just when you thought we could completely dump all the information from last chapter, you can't, because we're going to continue to use that. Okay, so we know that the length of half of our little b is 3.5, because we cut that triangle in half. And we know that this is 7. 30, 60, 90 triangle says that this distance here is the short leg times the square root of 3. Because you got short leg, you got your hypotenuse is double your short leg, and then your medium leg is your short leg times square root of 3. Okay, so the height of our triangle is 3.5 times root 3. So I've got, I don't have the area of the base yet. Still working on it. 1/2 7 times 3.5 or 3. Sorry, I ran out of room. So let's get the area of the base as a decimal approximation. So we're going to go 1/2 or 0.5 times the base of our triangle, which is 7, times the height of our triangle, which is 3.5 times root 3. So my base is approximately 21.2. So the area of this base is approximately 21.2 square meters. The next piece of information we need is the perimeter of the base. And that's still in. What's the perimeter of our triangle? It is 21. Beautiful. And then now we need the height between those bases, which is what? Grant?
5.
Yeah, it's 5. So this is 8. So let's go ahead and grab that formula. Surface area equals 2 times the base area plus perimeter times height, and plug in what we got. Area of the base was 21.2, perimeter is 21, and that height is 5. 21.2 times 2 is 42.4. 21 times 5 is 110. Nope. 20 times 5 is 100. 1 times 5, so it's 105. Sorry. I got a little crazy on the 5 there. And then 105 plus 42. 147.4. Guys, check my math on that. Meters squared. So the surface area is 147.4 meters squared. If I got separated from this formula, 2 times the base plus perimeter times height, just remember area of the front triangle plus area of the back triangle plus the rectangle on the left plus the rectangle on the right plus the rectangle on the bottom. So if you get separated from this formula, don't let logic lead your brain as well. You're just finding the area of each shape and adding it together. All right. What is the surface area of the rectangular? This is bonus. I don't think it's on your paper. Rectangular base prism. So I'm just going to show you it one more time. So our base has an area of 16. It's 4 times 4. The perimeter of our base is 4 plus 4, 8, plus 4 more, 12, plus 4 more, 16. And then the height of our prism is 4. This is 32 plus 64. Don't ask me why. I know 16 times 4 is 64. I just do. And then that would be 96. So on a shape where you can find the area of the base pretty quickly, this formula works. It's not as arduous as some of the other shapes. Okay, that was just bonus. All right, we're on Maddie. Can you go ahead and pull the definition of cylinder for us? So a cylinder is a solid with congruent circular bases that lie in parallel lines. And I always think of it, it's like our soup can. So it's got a circle on the top, circle on the bottom. Connected with lines. And I'm demonstrating. So when I take a cylinder, this is my little soup can. Oh, I had chicken noodle soup today. So when I take my soup can and I take my tin snips and I snip along my tin can and I unfold it, what shape does the sides of my can make when I unfold it?
It's a rectangle.
It's a rectangle. So if I were to unfold this cylinder here, I would have a rectangle, and then I would have, of course, circle from the top and the circle from the bottom. Circle from the top and the circle from the bottom would still be there. So when I'm looking at this formula, 2 times the area of the base, what is the area of a circle? We just took a test on this. This may be why some of you guys need to review this information. Pi r squared. So I find the area of the circle and I multiply it by 2 because I have 2 circles here. Now if I were to fold this back up, so here's my rectangle, if I were to fold it back up, you can see that the top of my rectangle has the same length as the circumference of my circle. So that's why they say C. So this is C for circumference. What is the circumference of a circle? Using radius, since that's what I have drawn. Circumference of a circle. 2 pi r. And then, so because the circumference is this top distance times the height of the can times the height of our soup can. So that's where I snipped up the side. This is the height of the can. So we're just finding the area of a rectangle. The top is the circumference of the circle, and the side is the height of our can. So the formula, so if you forget, like completely forget the formula, 2 times the area of the base plus the circumference times the height, you can just say, I know how to find the area of a rectangle, I know how to find the area of the circle, I have one rectangle that makes the sides for the lateral area, and then I have two circles, one on top and one on the bottom. Okay, so we're going to find, by the way, this is a bonus formula. I'm giving that to you, my gift to you. You can use it for any cylinder. So we're going to use the radius of 3 and a height of 4. We're going to plug it into this surface area formula. Pi times 3 squared plus 2 times pi times 3 times the height of 4. Okay, we do our exponents first because it's order of operations. 2 times pi times 9. 2 times 3 is 6. 6 times 4 is 24. I'm going to put the pi second. 2 times 9 is 18. 18 pi's plus 24 pi's. Since today we're having pi. Squared is 42 pi feet squared. Okay, so we're going to find the height of a cylinder, and let's go ahead and practice drawing a cylinder together. So to draw an amazing cylinder, I know you guys are flabbergasted. You draw an oval, so not a circle, but an oval. So it's kind of flat. Draw a line, 2 parallel lines coming down from the edges of your oval, and then just draw the bottom of your oval to represent the bottom of your cylinder. It's fun drawing with apple guard. Fun drawing with apple guard. If you want to get all crayon me, you can do a hidden line. Hidden lines are usually represented by dashes. My smartboard does dots a little better than the dashes. So if you're feeling like getting crazy, you can show that hidden line with a dashed part for your oval. All right, so the height of a cylinder, we want to find the height, so we don't know h. When our radius is 6.5, so let's go ahead and pull out our surface area formula, and it was 2 pi r squared plus 2 pi r h. Let's plug in what we know. 592.19 is the surface area. The radius is 6.5. Let's simplify that together. I'm going to shove pi into my answer, but not until this next step. So 592.19, 6.5 squared is 42.25. 2 times 6.5 is 13. 2 times 42.5 is 84.5. I'm going to go ahead and find this number here, 84.5 times pi, so that I can subtract it from both sides. I'm going to use the pi button. Please use the pi button every time. Every calculator that I provide you with has a pi button, so we're going to use it, and we're not going to use 3.14 because it deviates us too separate. It gets us, the answer becomes too far apart.
That isn't pi more than that though.
3.14?
Yeah, but like more than what's on that calculator.
Yeah. So far, yeah, it is. It goes on forever.
Is it? Really?
Uh-huh. It's irrational. That's the definition of irrational. So we're going to multiply 84.5 times pi. We get 265.5. I'm going to keep this as 13 pi. 592.19. I'm going to subtract 265.5 from both sides. And I'm a giant writer, so I'm just going to move these guys in. Come on, buddy. Okay. And negative plus 592.19. That's 326.7 equals 13 pi h. In order to get h by itself, I'm just going to divide both sides by 13 pi. So divided by, let's see, 13 times pi. And let's go ahead and round that to 8 centimeters. A little bit of solving equations thrown at you guys. Good thing we were practicing that the entire school year, so we don't get too separated from our algebra skills. All right, we have a cylinder with a hole burrowed through the middle. So this hole goes all the way through. Remember, hidden lines are so it goes all the way through the cylinder. So when we find the surface area, we're going to find the surface area of a regular, instead of finding the area of the entire circle on the top and the bottom, we're going to subtract out the little circle before we multiply it by 2. Then that smaller hole in the middle, we're going to have to add that to our surface area. So normally we would just be going outside of the cylinder. Now we have that inside burrowed out hole. We're going to have to find the surface area up, but that's okay because we know it's the circumference times the height. So we're just going to add that to our surface area calculation. Okay, so of the regular cylinder, let's find the area of the base minus the hole. So so that's the area of the big circle minus the area of the little circle. So when we're looking at area of the big circle, we got pi times r squared. We're going to do the same thing with the little circle. We just have to determine what the radius of each of those items is. So if I were to start here at the middle and go all the way to the edge, what would the radius of our big circle be? 1.5. Each one of these tick marks is 1. If I'm starting at the middle, I only get half of 1. And then plus 1 more. So this is 1.5. And then what's the radius of my tiny guy?
0.5.
Yeah. 0.5. Right, so this is 1.5 squared is 2.25. You can be impressed now, but I did do this yesterday, so it's kind of like cheating. 0.5 squared is 0.25. And 2.25 pi minus 0.25 pi is how many pi's? So the area of our base is 2 pi inches squared. So that takes care of the top. So we're going to do the bottom. We're going to do that's the top and the bottom, so I'm going to double it. Because I have two bases. So let's do a total area calculation down here. 2 times 2 pi. Takes care of the two bases. Let's do the lateral area, the huggy area. So we're going to do we'll call it lateral. Remember, that's just a rectangle. It's the circumference of the big circle, which is 2 times pi times 1.5 times the height of that cylinder, which is 12. 2 times 1.5 is 3. 3 times 12 is 36. So the lateral area of the hugging area is 36 pi. The last little piece of area I have to find is that of the burrowed out hole. So if I were to snip that burrowed out hole, I would get the circumference of the little hole times the height of the cylinder. So this is the hole in the middle. So that's 2 times pi times the radius of our little one, which we said was 0.5, times the height of the cylinder, which is 12. 2 times 0.5 is 1, and 1 times 12 is 12. Okay, so now our total area is 4 pi plus 36 pi, that's 40 pi's, plus 12 more pi's is 52 pi. Inches. So sometimes you just need to think logically about it. I'll leave that up for a second while you guys finish writing. Any questions on this problem? Found the area of each of the bases, the lateral area, hugging it around, and the area of the burrowed out inside. Okie dokie. So I'm going to put 20 minutes on the clock, actually technically 22.